All right, so today is Thursday, the 17th. We're going to do the warm up. We're going to write some things in our notebook. We're going over roots today. We're going to finish the cut paste activity and start and do some ordering of numbers by converting them to decimals and putting them in order from least to greatest. Isaiah, you okay? Can you tap him, see if he's okay, babe? Isaiah, are you okay? Okay. All right, your homework for tonight, guys, your homework for tonight is the makeup work. Please do not forget to submit your makeup work and do not forget to upload your pages in your interactive notebook to the to Canvas. Any questions about how to do that? Maddie, did you write this down? I'm going to pause to give you a chance to write, and then we're going to write in our planner. Make sure we know what the expectation is. All right, in our planners, remember I'm checking your planner next Tuesday or Wednesday. The end of the quarter is Thursday, so it has to be Tuesday or Wednesday. This is week, sorry y'all, 8. This is what we should have. Today's Thursday, again, the 17th. Our homework is in pencil. There is no homework. You're just working on your makeup work and making sure that you upload your interactive notebook to Canvas, which is due tomorrow. Everything is tomorrow. Any questions, comments, or concerns? Yours is written in pencil. This is you, Math 8. And I'll pause to give you a chance. Please go ahead and mark off if you worked on makeup work last night. Bless you. Check it out. If you uploaded your pictures to Canvas from your digital interactive notebook or your interactive notebook, check it out. We have 20 pages. I'm going to pause for the cause. Let's do the warm-up. Please mark out Friday. Oh, yeah. You said, can you answer it? Yes, go ahead. Shh. Go ahead. Here, this is not reflection because it didn't flip. Remember, there are 4 transformations. 4. It is.
That's what it is.
Shh. Y'all, calm down. I heard all of each of you. The first one is translation. What does it mean to translate? This one is to slide. The second one, somebody said reflection. What does it mean to flip? And then rotation is what? To turn. And then what's the last one?
Dilation.
Dilation. And what's dilation? To either get bigger or smaller. Shh, please don't do that. All right, so this transformation is a slide. They slid it. So this is translation. Which one is the image and which one is the pre-image? Pre-image. Let's start with pre-image first. Say it again, baby. Pre-image is the before the move. The image is after the move. So the pre-image is the one is where it started. Which one is where it started?
Quadrant 2.
This quadrant right here too. This is pre-image. Very good. And the image is where it moved to. This is the image. How did it slide? Pick one of the points. Let's pick A.
6 to the right, 4 down.
And A. Okay? Think about it, and then we'll see if you're right. Okay, we do have one guess. Anybody else? All right. How far did you slide to get from A to A prime. You went over to the what? Went over to the right. How many times? 1, 2, 3, 4, 5, 6. Very good. So this is x plus 6. Went 6 to the right. If you went to the left, that's x minus 6. And then you went down. Very good. 1, 2, 3, 4. So that's going to be y minus 4. This is the rule. Let's pause for the call. The second one, you're solving this equation. So your first step is distributive property. You're going to multiply. You see this -8 times both numbers in the parentheses. Distributive property is first. We're going to bring down this 6g. And we're going to multiply -8 times both numbers in the parentheses. What's -8 times a positive 2g? Negative, somebody says 16 what? G. Come on, guys, not necessary. Come on. A -8 times a -3. Positive 24. Bring down the equal, bring down the 2g. Now we're going to combine like terms on each side separately. Nothing to combine on this side, so let's just bring this side down. It's only one term over there. Just bring it down. But on this side, what terms can we combine? 6g minus 16g. What does that give us? What kind? -10g. Very good. Bring down. Very good, babe. Bring down the positive 24. Now we got to get the g's to the same side. So let's move the 10g since 2g is already on the side by itself. How do you move a -10g to the other side? Add 10g. So it's a -10g, so add it to move it. -10g plus positive 10g is 0. And we're left with 24 on this side. Positive 24. 2g plus 10g is what? 12g. Very good. What number are we going to divide on both sides to get g by itself? 12. Just the 12, okay? G is okay. We're going to divide both sides by 12. What's 24 divided by 12? 2. And 12 divided by 12 is 1. So this is 1g or just the g. So g is equal to 2 or 2 is equal to g. Same thing. We'll pause for the calls. Please write this down. All right. Okay, let's take out. Not during this class. All right. Put this out in front of you, please. We've already started this. I'm going to put these numbers down once more for you, just in case, for those of you that missed this on yesterday. I'm going to review this part once more with you. And then you're going to do some of these on your own. We cut the bottom half off. I'm going to do this first row with you again. I think maybe the first 2 rows is what I did. Okay, and let's see if you remember. This is the first row. If you haven't done that, please cut just the first row so you can keep up with me. Don't start doing individual because you're going to get lost at trying to find the numbers. So just do one row at a time. Any questions? Is there anybody that's not ready for me to go through these? We're going to glue at the end. All right, here we go. This first number right here, the square root of 34. Where does that go? Is that rational or irrational? Which one? It's irrational. It's a non-perfect group. Please make sure you put that under irrational. If it's irrational, all it can be is a real number and irrational. That's it. The second number. And please make sure you just raise your hand if you feel like I'm moving too fast. We are not going to glue down until the end because I'm limited on glue sticks, okay? 1,234. Is that rational or irrational? It's rational. You can write this as a fraction. Is it an integer? Is it an integer? Yes or no? Yes, it is an integer. It does not have a fraction attached to it. It does not have a decimal attached to it. Okay? It's a positive or negative number. It's a positive number. Okay? So it's an integer. It doesn't have any fractions or decimals attached. Is it a whole number? Yes. It's not negative, and it does not have a fraction or decimal attached. Is it a natural number? Yes, it's a counting number. You might not want to count that high, but you could. That goes under natural. We put it in a natural box because the natural box is automatically in the whole number box, which is also in the integer box, which is also in the rational box. So this number is a whole number also. It's also an integer, and it's also a rational number. Okay? It's in all of those boxes. Let's do the next number. Remember, we'll paste at the end. We have this long decimal here. It does not have the dots on the end. So is this terminating decimal? It stops. Is it rational or is it irrational? It's very rational. Okay. Is it an integer? Yes or no? It is not an integer because it's a decimal. That means it can't be any of these either. So it's only a real number and a rational number. Remember, I'm only doing one row at a time. That way I don't confuse anybody and you don't get lost by looking at all these different numbers, okay? Negative square root 34. Is that rational or is that irrational? It's irrational. It's a non-perfect group. It's a negative non-perfect group. Now, it is still irrational. If it's irrational, it can't be anything other than a real number and an irrational number. The next number, negative 97. Is that rational or is that irrational? It's very rational. You can write this as a fraction, okay? Remember, there are only 3 types of irrational numbers: pi, non-perfect roots, and those decimals that have the dots at the end, okay? All right, is this an integer? Yes, it is. It's a negative number that does not have a decimal attached or a fraction attached. Is it a whole number? No. It's a negative number, so it's not whole, okay? So we put this under integer, all right? Integers are also rational. You see how the integer box is also in the rational box? It's both of those. It's also a real number. Every number is a real number. Okay? The next number is this 14 and a 0.4 repeating. Is this rational or is this irrational? It's very rational. I know what number is coming next. So I can write this as a fraction because I do know what number is coming next. Is it an integer? No, because it has a decimal attached. So it is just real and rational. Let's do the next row. Please cut out the next row. This is the next row. Raise your hand if you're not ready, and I'll wait for you. DJ, sit up, baby cheeks. All right. Let's cut out negative pi. Look at this. Is this rational or is it irrational? Irrational. It's irrational. Pi is irrational. You do not know what number is coming next. It does not have a pattern as to how it repeats. It continues on forever and ever, and it doesn't have a pattern. Let's cut out the next number, which is 135. 135. Is that rational or is that irrational?
Rational.
It's rational. Very good. You can write it as a fraction. Is it an integer?
Yeah.
Yes. It does not have a fraction attached to it. It does not have a decimal attached to it. Okay. Is it a whole number?
Yes.
Yes. It's not negative. It doesn't have a fraction attached. It doesn't have a decimal attached. Is it a counting number?
Yes.
Yes. Okay. So it is all these things. The next number we're going to cut out is negative square root 36. One row at a time so you don't get lost. Raise your hand if I'm moving too fast. Okay. So we're looking at this one. Is this rational or is this irrational? The square root of 36 is equal to what? You do have a calculator. Please type that in. What one number can be multiplied times itself to give you 36? 6. So it is rational. This would be, the answer here will be a negative 6. Okay? So it's rational because when you simplify this, it's not a decimal. All right? Is negative 6, which is this answer, is that an integer? Yes. So we put it here. Is it a whole number? No, it's not a whole number because it's negative. So this number goes here. Any questions? The next number from our list is 3. So we're cutting out 3. Is 3 rational or is it irrational? It is rational. You can write 3 as a fraction. Is 3 an integer?
Yeah.
Yes, it is. Is 3 a whole number?
Yes.
Yes, it is. Is 3 a counting number?
Yeah.
Yes, it is. The next number is 6.2. 6.2, is that rational or is that irrational? It's rational, okay? It doesn't have those dots at the end of the decimal, okay? So this is a terminating decimal. It actually stops. Is it an integer?
No.
No, because it's a decimal attached, so it's not an integer. So it's real and rational only. Okay, the next number we're going to cut out is this 6.5892. That's the next one we're going to cut out. And remember, this is the 10th place, the 100th place, the 1000th place, the 10,000th place. So this is 5,892 10,000ths. That's how you say that number technically. All right, is this number rational or is this irrational? It's very rational. You don't see the dots at the end. This is a decimal that stops. So it is rational. Is it an integer? Is it an integer? No. Okay, decimals are not integers. So it's just rational and a real number. Look at our list. The next number is negative 14.4. Is this number, is it rational or is it irrational? It's very rational because it stops. It's a decimal that stops. Doesn't have those dots at the end. Is it an integer?
No.
No, it's not an integer because it has a decimal attached. So this is just rational and a real number. Every number is a real number. We okay? The next number is 1. Is one rational or is it irrational?
Rational.
It's very rational. Is it an integer?
Yes.
Yes. Is it a whole number?
Yes.
Is it a counting number? Yes. The last number from that row is 2 pi. Is 2 pi rational or is it irrational?
Irrational.
Irrational because pi is an irrational number. Okay. Now we're cutting out this next row here. Okay. It does. It starts with 0.777. So on. Yeah, repeated 7. All right, let's look at it. Is this rational or is it irrational?
Rational.
This is rational. Okay. It stops, and they may indicate that this is a repeated decimal, but you know what number is coming next. So either way, this is going to be rational. Is it an integer though?
No.
No, because it's a decimal. That means it can't be anything else either. So this is only rational and a real number. That's it. I don't know. You got to count them. I didn't either. 7, 7. Let's look at the next number. The next one we're cutting out is the square root of 81. The square root of 81, is that rational or is that irrational?
Rational.
It is rational. The square root of 81, what is that equal to?
9.
It is equal to 9. So is the square root of 81, which is 9, is that an integer? Yes, it is. Is it a whole number? Yes, the answer is a whole number. Is it a natural number? Yes. Let me cut this down a little bit so it'll fit. The answer is 9, which is also a natural number. The next number that we are cutting out is the square root of 300. Tater, do you already have this done? You need to be working on this, babe. The square root of 300. Is the square root of 300 rational or irrational?
Irrational.
It's irrational because when you simplify it, it's a decimal. Okay? Come on, DJ, write this in. Okay? The next number is 42,260. Is this number rational or is it irrational?
Rational.
It is rational. Okay, you can write this as a fraction. It's a big fraction, but you can write it as a fraction. Is it an integer?
Yes.
Yes, it's an integer. Is it a whole number? Yes, it's a whole number. Is it a counting number? Yes. We might not want to count that high, but we could. Cut it down just a little bit. All right. The next number is negative 13.574, which this last place value, remember this is tenths, hundredths, thousandths. So this is negative 13 and, that's a decimal, 574 thousandths with the THS. That's how you technically say that number. Yes, baby.
We only have 2 minutes, so we're not going to glue them down.
Oh, we got 2 minutes?
Yeah.
That's too fast. Let's glue. Let's go ahead and glue this one in. This is rational. It's a decimal that stops. If you have glue, please use your own glue. You already glued. You got glue? Oh, I don't know who's calling. Yes. Can you share with the person that's around? Can you pass this back and let the lady share? And then where's your list? Where's your list? Okay, anybody want to use just tape these theirs down? Anybody want to use tape? That's what I did. It made it go by faster. I just put a good piece of tape over it instead of gluing each individual. I just took like 2 pieces, 3 pieces of tape and glued it down. Cheating, I guess, maybe. Yeah. Okay. I just covered it with tape and moved on with my life. All right, one person please take up the calculators from your row and put those back. All right, we're gonna stop it here.